In this lesson, we'll be discussing the application of Pythagorean theorem. So by the end of the lesson, you should be able to draw a picture and determine the legs and the hypotenuse from the word problem, and then use the Pythagorean theorem to solve the word problem. So to start with, we're going to make sure we understand the difference between squared and square root. So in the first three examples here, we have the side, and so we need to find the area. So in the first one, the area would be 4 units squared. In the second one, it would be 9 units squared, 3 times 3. And in the third one, it would be 25. But sometimes you have to find the side because you've been given the area. So in this first one, this red box, it says the area is 64 units squared, so that means the side is 8. In the second one, the area is 225 units squared, which means the side is 15. And as the third one, it says 324 units squared, so that means the side is 18. So when we're breaking down a word problem, the first thing you want to ask yourself is, what do I know? Do I know how long the leg is? Do I know how long both legs are? Or do I know how long the hypotenuse is? So what am I looking for? Am I looking for a leg, or am I looking for the hypotenuse? Then when you get your answer, make sure it's reasonable. Okay, did you come up with the hypotenuse being the longest side? If you're looking for C, make sure it's longer than the other two. We also need to make sure that the sum of the legs, the two legs together, have to be longer than the hypotenuse, or it can't be a triangle. So those are two questions you need to ask yourself to make sure that your answer is reasonable. So the easiest way to handle a word problem is by drawing a picture. That always helps. And then write your equation, and then you use your Pythagorean theorem to solve. So this first question says a 17-foot ladder is resting against a wall. The base of the ladder is 8 feet from the wall. How high up will the ladder reach? Are you confused? Yes, probably. So if you draw the picture, so here's our ladder, and it says the ladder is 17 feet. So you can see that that ladder is on the diagonal. So you know that that's going to be C. Then it says it's 8 feet from the wall. So you can see here at the bottom, it's saying that the ladder is out from the wall by 8 feet. And so it wants to know how high up it's going to reach. So that means we have C, and we have one of the legs, and we're looking for the other one, which means that it is a subtraction problem, right? Because we have a squared plus b squared equals c squared. We're missing a, we're missing one of the legs, so it's a or b, doesn't matter. Then we have the other leg equals 17 squared. So in this case, I need to solve for a. So first thing, a squared, 8 squared is 64, 17 squared is 289. I'm going to subtract 64 from each side and get a squared is 225, so a is 15. So if I look back at my problem, the legs are 8 and 15, and the hypotenuse is 17. Yes, it's the longest side. If I add 8 plus 15, that's 23. So together, those are longer than the hypotenuse. A commuter flies between 3 cities. They are 350, 300, and 200 kilometers apart. Do the pass between the cities form a right triangle. So the first thing I'm going to do is draw that route. It's saying between the 3 points, one of them is 200, one is 300, and one is 350. Well, I know 350 is the hypotenuse because it's the longest one. So I use my equation and I plug them in, 200, 300, and 350. Now I'm going to solve it. 200 squared is 40,000, 300 squared is 90,000, and 350 squared is 122,500. Do they make a right triangle? No, they do not. If the path from first to home and from first to second is 90 feet, how far is the throw from home to second? Okay, let's draw that field. When from home to first is 90, from first to second is 90, how far is this throw from home plate to second base if they're trying to steal? Well, you can see that if you kind of turn your head, you can see that that is the longest side, so that's going to be the C side. So I'll plug in A and B, so we have a squared plus b squared equals c squared. Now I need to see how long is C. So 90 squared is 8100. 91 squared is 8100 equals c squared. 16,200 equals c squared. I added 8100 and 8100. And then I'm going to take the square root of 16,200, and it's about 127 feet. Not exactly. So all squares have 90-degree angles, and all squares have 4 sides that are the same length.